And hello there. Today we're going to look at differentiating fractions. If y is a function of u divided by a function of v, where u and v are both functions of x, then dy dx is equal to v du dx minus u dv dx all over v squared. It sounds like a bit of a mouthful and it looks quite scary when you see it written down, but honestly it's not hard to use at all. It's just a little bit of differentiating and putting things in the correct place in the formula. If you can follow it, you're doing very well. All over v squared there. Make sure you get the minus in the middle. That's the bit people tend to forget with these questions. So to use it, we're going to look at this very easy peasy example. We're going to differentiate 3x all over 1 plus 2x. So I'm going to start by looking at the top line, which is u. I'm going to call the bottom line v. I'm going to do these in different colors, just so you can see where all the pieces are assembled together. If u is 3x, differentiate the top to get 3. In much the same way, if v is the bottom line, 1 plus 2x, differentiate that as well to get dv dx, and that should give you 2. Now we have all the pieces we need to put into our formula. So again, dy dx is v du dx minus u dv dx all over v squared. All the pieces are there in front of us. I'm going to start with our top line, make a nice big long line. I don't think I made mine quite long enough. Then v times du dx is 3 times 1 plus 2x. Again, I'm writing mine in colors just so you can see where they go. I'm not worried about simplifying it yet. I'm just getting the pieces into the correct place first. There will be marks for this in an exam. So keep it simple, keep it straightforward. Don't try to do too many things in one go. Now the bottom line, v squared is 1 plus 2x, all squared here. Do not multiply out that bottom line. Keep it as a bracket squared. It's just easier if you do. Now, the top line, though, we are going to expand out, but only the top line. So if I multiply those brackets out, 3 times 1 plus 2x should give me 3x plus 6. And again, it's important to keep the bottom line as a bracket. It looks simpler, it's less work to do, and it's probably more useful for a follow-up question to keep it in a bracket. And that's all divided by 1 plus 2x all squared. And the last step for this question should be fairly self-explanatory. Simplify the top line. 3 plus 6x, take 6x. Should leave you with just 3. So your answer is 3 on top of 1 plus 2x all squared. With this question, it's basically the same as the last one. We're going to differentiate a fraction, but this one has a bracket on the denominator. That's not a big deal. Do not expand the bracket. Keep it as a bracket. So we'll take the top again as u. If u is 5x minus 1, then du dx is 5. Easy peasy. The bottom line, v equals 4x plus 3 all squared. Hopefully, at this point, you know how to differentiate brackets. We differentiate the bit inside the bracket, 4 plus 3x. That gives us an answer of 4. And we multiply that by the power to get 8 on the outside, and then take away a 1 from the power. You don't need to write a 1 there, but I did anyway, just to keep myself right. After that, as before, you put all the pieces in the correct place. It's a bit long-winded, this one, but it's not difficult. So dy dx is a rather large fraction. We're going to have v times du dx. So that's 5 times 4x plus 3 all squared. We're going to take away u dv dx from that. So u dv dx is going to be 8 times 4x plus 3 times 5x minus 1. Again, I'm writing it in colors just so you can kind of see where all the pieces are assembled together. And since that's all over v squared, 4x plus 3 squared, if you're squaring a square, you get a 4. So it's 4x plus 3 all to the power of 4. Now that's our pieces in the right place. That will get you marks in your test. From there, you will probably be expected to simplify it. Now, to simplify this, I'm going to cancel off a common bracket. Each term has at least one bracket of 4x plus 3. So I'm going to cancel off one 4x plus 3 bracket from each of these terms. So, top line, if I look at that first, if I take out a 4x plus 3, I'm going to be left with 5 times 4x plus 3 to the power of 1. If you like, I've taken away one of the brackets to leave me with 1 left. Here I'll be left with 8 times 5x minus 1. I've cancelled off a 4x plus 3. And on the bottom, if you're cancelling off a 4x plus 3, you will not be left with the power of 4 as I've written. I'm going to scribble that out and write 3 because I've got 3 of them left. From there, as before, you multiply only the top line of your fraction out. Do not multiply out the bottom line. So if you times it out correctly, 5 times 4 is 20x, 5 times 3 is 15, take away 40x, take away 8. Plus 8, sorry. Minus 8 times minus 1 is plus 8. All divided by 4x plus 3, all cubed. And again, your last step, as before, simplify what you've got on top. So I can see a 15 add 8, which is 23. And a 20 take 40x, which is minus 20x. All divided by 4x plus 3, all cubed. Most of the time, you should never ever multiply out the bottom line. For our next example, we're going to use trigonometry and a fraction. If you haven't got to the part of your course yet where you know how to differentiate trigonometry, then you probably shouldn't use this example yet. Come back to it after you've covered that. But if we learn how to differentiate tan of x, very easy one. Tan of x is the same as sine divided by cos. You do need to think of tan as a fraction in order to differentiate it correctly. Our top line is u, which in this case is sine of x. To differentiate sine of x, you simply get cos of x. Sine turns to cos if you differentiate. On our bottom line, v is cos of x. To differentiate cos of x, you get negative sine of x. There's all our pieces in play. Now we simply write our rule and put our pieces in the correct place. So dy dx is going to be v du dx minus u dv dx. So v du dx is cos times cos, which is cos squared. U dv dx is sine times minus sine, which is minus sine squared. And that's all divided by v squared, which is cos squared x. From there, we're going to simplify it a little bit. I'm doing a little bit at a time just so I don't get lost. I'm going to evaluate my two minus signs, and minus means u plus. So our top line is actually just cos squared plus sine squared divided by cos squared. And since we know, hopefully you do know, that cos squared plus sine squared is equal to 1, our question is 1 divided by cos squared. And again, if you've gotten far enough in the course, you should know that 1 over cos squared is the same as sec squared of x. And for our final example, we're going to look at differentiating exponentials and logarithms contained within a fraction. As long as you differentiate each part correctly and put them in the right places in your rule, this isn't too difficult. To differentiate the log of x, you should get 1 over x. On our bottom line, v equals e to the 3x. If you differentiate e to the 3x, you actually just differentiate the power. Differentiate 3 to the x, you get 3. Slap it in front of e. So 3e to the 3x. And as before, use the rule, put the pieces in the right place, and simplify as best you can. So dy dx, again, is v du dx minus u dv dx all over v squared. So v du dx is e to the 3x times 1 over x. U dv dx, and I'm minusing it because it's minus u dv dx, is log of x times 3e to the 3x, all divided by e to the 3x, all squared. I haven't simplified it yet. I'm about to in my next step. Simplifies very easily this question because everything has e to the 3x in common. So I'm going to cancel off my e to the 3x from each term. So I should be left with 1 over x first, subtract 3 log of x after that. And since I've got e to the 3x squared in the bottom, one of those e to the 3x cancels off to leave me with 1 at the end. So I'm left with e to the 3x. And my question is complete. Thanks for watching. Feel free to click like and subscribe.